So today we're going to be looking at concave mirrors, and I want to share with you the flat mirror, which is the plane mirror, and you can see that this is flat like the flat plane of a surface. There are two other types of mirrors, and one is a concave and one is called a convex mirror. And think of a cave. If you go into a cave inside of a mountainside, the cave bends inward toward the mountain. So if you can imagine a mirror like this and an object being right here, this is curving inward. This is the flat surface here, and it curves or bends inward. This would be an example of a concave mirror. Example of a convex mirror is the opposite of concave, and that would be if you have an object and you have a mirror that's bending the other way. This is a convex mirror. So we're looking at concave mirrors for today. And we're going to be needing our ruler again, and there's going to be lots of terminology and a lot of drawings. And so I just want to make sure that everyone is going to be following. If you have any questions, please let me know. So what I've drawn here is a round circle, and the round circle is actually going to be representing just a portion of the mirror. So imagine that instead of course, if we had a circular mirror like this, let me see if I can get that like this, okay? On the inside, we wouldn't be able to get any light or image coming from the outside. So we're actually just looking at the curved portion on this side over here. So the mirror extends from here to here. This is our actual curvature of the mirror. So if you can label that as the mirror, and then this goes around and then continues to come around, and then the mirror will end right about here. Okay? That's the first thing. And this is going to be the central line or the center of the curvature of the mirror, and this is going to be called the principal axis. The principal axis. So again, our mirror is here and it's curved, and this principal axis is going to be going right through the center of that curved mirror. Since this is a circle, what we have is we have the center of our circle. Yes, we only have a portion of the mirror, but if that curved concave mirror could form a circle, this would be the center right there. So this is defined as the capital C for the center. What I'd like you to do is to measure with your rulers this right here, and you actually will have had to have printed this off already, so hopefully you have that printed off and you're doing this on regular paper. And this is about 7.5 centimeters. We want to find the halfway point of 7.5, which is going to be about 3.75 or maybe close to 3.8. So we have the center of what would be the circle of our mirror, and we have this right here, which is called the focal point, and it's capital F for focal point. We'll get back to the center and the focal point a little bit later. Now, this is going to be represented as point A, because this is a line that lies right on the actual mirror itself. So if I had CA, this is a line that's extending from the edge of the circle to the center. This would be what of my circle going towards the center? This would be my radius. So segment CA is going to be known as the radius. Okay, again, F is our focal point, and we also have this length that goes from here to here, which is represented as a lowercase f. This lowercase f is the focal length. So lowercase f is equal to the focal length. And therefore, the focal length, which is also equal to the segment FA, is equal to what portion of my radius? It's going to be equal to 1/2 the radius. Okay, or the radius can also be seen as equal to twice whatever the focal length is. Okay, so here the focal length is equal to half of the radius or 1/2 the radius. So you might be given the radius in part of a problem, and you have to calculate what's the focal length. It's just going to be half of that radius. This, let's go ahead and go on to another topic here, and this is going to be the rays of light that are going to be coming in. So we have this principal axis, which is coming to this point here. We also have this line, which is a very strange line, and this is the line that's going to be perpendicular to the principal axis. And for the purposes of all of our mathematics, we are going to be having the beam of light coming in, but it's not going to be hitting the curvature of the mirror. Of course, it would be hitting the curvature of the mirror. Okay, if I have my mirror that's facing like this, and I have a light ray that's coming in, boom, it's going to hit this because it can't go through. But for the purposes of the mathematics works out beautifully that if this ray of light passes through the mirror and hits this line behind the mirror, then we're going to be getting some good mathematical measurements from this. So we're going to draw a ray of light coming in, and it's going to be coming in parallel. So if you can draw this line coming in parallel, this is going to be ray number 1. And again, we're going to draw it. In reality, this light ray would reflect off of the mirror. But what we're going to do is we're going to draw this past the mirror and then hitting this line that's perpendicular to the principal axis and goes through point A. Now, what's going to happen here is this is going to hit it. Now, imagine that this mirror is composed up of an infinite number of small flat mirrors. So if you remember the concept of a circle is composed up of an infinite number of infinitely small flat surfaces. So there are tiny little mirrors that are each one of them are flat. So if a beam of light comes in, we're going to have a regular reflection off of that, and it's going to bounce off of that mirror. But again, it's going to be bouncing off this point right here. So we're going to actually take this portion of the mirror and we're going to be putting it right there. And imagine that it's right there. What's going to happen is this is going to have a regular reflection, and it's going to be having the reflected ray go through the focal point like this. So here is ray number 1. Ray number 1 comes into the mirror. It's hitting this line that's perpendicular to the principal axis, and we're having this regular reflection. You can imagine if this is the mirror surface and this is actually the normal, this would be the reflected ray of light. Now we're going to take a look at ray number 2. You can also draw this parallel. Ray number 2 is going to come in. We're going to draw it through the mirror to hit that line behind the mirror, and it also is going to come through the focal point. So there's this concept. Let's go ahead and label this ray number 2. There's this concept that parallel rays that come into a concave mirror are going to meet at the focal point. So rays parallel to the principal axis exit through the focal point. That's what is happening right here. And so what we have here is we have this first reflected ray here. This is coming from ray 1, and this is coming from ray 2. Again, these are the reflected rays. So this is going to be reflected ray 2, and this would be reflected ray 1. So as a summary, we're going to be using the circle to represent the mirror, but we're only using a portion of the mirror. And for our mathematics and for our drawings, we're going to be using this line that's perpendicular to the principal axis. And parallel rays that come into the mirror are going to be exiting through the focal point. Here's our center, here's our focal point. The focal point is going to be half of the distance of the radius, and this is also called, 1/2 of the radius is also called your focal length.